Hello everyone and welcome back to another video from the Hidden Quantum Champion series here on the Polaris School of Quantum channel. And with that, let's look at today's company, which is really a truly hidden champion that probably people that are interested in the field of quantum technology might not even have heard about unless you've actually worked in a lab that is doing some type of solid state related quantum computation, or if you have worked in any, let's say, other area that is related to cryogenics, because in today's video we are looking at Bluefors. So with that, let's hop right into it. Here we are on the website of Bluefors. We see this very fancy chandelier-like looking structure here, gold-plated, which is actually an opened up dilution refrigeration cryostat. You see here the radio frequency lines going down to these plugs here, and usually down here is where your, let's say, qubit chip would sit. Behind here you can also see the different vacuum tubes and stuff that you need to actually perform this cooling, this helium cooling that is actually needed to create those super low temperatures. And then there are some additional ports here for all other types of wiring that people might need down there. It says, delivering the quantum future today, Bluefors builds the world's most accessible, innovative and reliable cooling solutions for quantum technology. Our systems are relied upon by thousands of scientists to cool bright ideas into reality. I like this phrase, cool bright ideas into reality. Then you have contact sales here, and down here there's like a running news feed. It says, cooling the world's brightest ideas into reality. So now we learn what this means. At Bluefors, we are on a mission to unlock the quantum future of everyone. We craft tools that push at the boundaries of physics to reach temperatures close to absolute zero, where quantum progress happens. We envision a world where everyone has access to quantum technology, and we all benefit from the transformative results it brings to our lives through advanced computational power, ultra-secure communication, or cutting-edge sensing technologies. Through collaboration, cooperation, and state-of-the-art innovation, we make the impossible possible and bring about the quantum leaps that will change the world. So if you say there's a gold rush around quantum, they are probably some of the people that sell the shovels, right? But this is, of course, not the only thing, not only for quantum computing and not only for quantum sensing. Basically everything that needs these super low temperatures might also be, I don't know, some gravity telescope, whatever that you're looking at, gravity wave telescope, that might require these super low temperatures. Then Bluefors is one of the companies that supply the tools for that. And you see this involves various different stages. You can also see it here. So there's of course the mechanical design, so people that have to mechanically build these components, and it's not an easy job because when they talk about zero temperature here, they mean zero temperature on the Kelvin scale, not on the Celsius scale. So you're going basically to the absolute lowest temperature possible, which is around minus 273 degrees Celsius, so very, very cold. And you can imagine that these systems, they are being built at room temperature, they're shipped at room temperature, then you cool them down, you might warm them up again, cool them down. So there's a lot of thermal cycling happening here, and you really have to build quite robust systems to actually be able to do this thermal cycling. Not only to mention also that, of course, we are working with very high vacuums here, so there's pressure differences between those pressured helium lines here and the vacuum that is inside this chamber. So there's like various different challenges on the mechanical side, but also on the signal side. So you see here these radio frequency lines, they have to be calibrated and set up in a way that they actually work for super high frequencies, so radio signals, radio waves. That is also not an easy job. And then of course everything has to be brought together and mounted together by experts. So you really need a lot of understanding and a lot of different stages and different expertises actually create such a system. It's kind of a technological marvel already in itself. And I think everyone who has worked on one of those systems for probably the last 50 years knows that it's not an easy thing, because there's so much stuff which can actually, there's so much stuff which can actually break, and in the past also used to break. And I think the Bluefors team is really pushing on that side to make this technology more reliable, to use new fabrication schemes, new technologies in actually producing and manufacturing those components here to make the systems more reliable, so that the downtime of your research equipment is actually less than it might used to be, so you can produce more scientific research with such a machine. Accelerating quantum innovation, we have over 1,500 systems installed and fully operational in labs and facilities worldwide. Here are just a few of our innovative customers. And I've also been working on one of these labs which had one of those systems, and here is Jülich also, you can see it. And I can say these systems, they're actually very nice to work with. But we also see other labels here like Alice and Bob, which we've seen before, IQM. There are also big brands like Fujitsu here, and D-Wave, which is a stock listed company in the space of quantum technology. And I'm not going to read all of them now, but you can see them. There's like, there's Quantum Motion, Quantum Machines, Rigetti that we've also been featuring, and many others that we've been featuring across this series here in the past. So find our cool solution. Find your cool solution. Physicists and scientists around the world rely on Bluefors to conduct research at temperatures colder than outer space. Our easy-to-use, innovative, and reliable cooling solutions makes it a breeze. Whether you are building a quantum computer, cooling your telescope to study the universe, or uncovering entirely new frontiers of knowledge, we will work together with you to make those breakthroughs possible. Explore our products designed for a lifetime of innovation. And then the Bluefors products and also Cryomag, I will talk about that in a second. But before that, maybe some quick walkthrough here. So what you see here, which is this hanging structure, this black hanging structure here, is what is the enclosure of this chandelier that you might know. So in here you will have the cooling system, which down here somewhere houses the quantum chip, the quantum computing chip, the processor, right? Like the superconducting one, for example. And then you have different stages in here, which include the different temperatures. So you have usually down here your millikelvin stage, which is where the chip will reside. Then you have a couple hundred millikelvin stage, which is still very, very cold. Then you have the 1 Kelvin stage, which is what you can get with helium if you actually pump on it. The 4K stage, which is helium at, let's say, ambient condition. Then you have at some point the stage which you can reach with liquid nitrogen. And then at some stage on the top, of course, you are at the room temperature level. And the electronics will probably sit somewhere here on top, like the electronics that controls your chip, that does the quantum computing. And there are also some companies that build this electronics, which we have already featured in the series, and there are some more which will be featured. And then, of course, there is the control electronics in here for the cooling system, but there's much more in here. And let me quickly also elaborate on those other things. So in order to cool to such cold temperatures, you need to have something else than just liquid nitrogen. So liquid nitrogen is good to create some initial cooling, but if you really want to go down to the quantum computing temperature requirement, you need actually helium. And so helium, if you are familiar with the periodic table, you will know that helium has 2 protons and 2 neutrons, making 4 elementary particles in the core, in the nucleus. Now, there is another isotope of helium, which is called helium-3, which has 2 protons because it's still helium, but only 1 neutron. So that's called helium-3. And now this has some different properties from helium-4, which, like, just the fact that you only have 3 spinning or 3 spin particles more or less in the nucleus already makes it behave differently when it comes to its quantum properties. And now if you create a mixture of those two helium isotopes, so helium-4 and helium-3, and you pump on it, you can actually create a phase transition which can remove thermal energy by going through this phase transition, and thereby more or less you can create this super low temperatures. And there's a very nice video of Professor Andrea Morello, I'm not sure. I will link it down in the video description, which you can check out, where he's explaining very well how this technique works. So you will have this, which means you need some turbomolecular pumps, which actually create those pressure differences in a closed loop. So you will have some pipes going out here, some pipes going in here, and some molecular pump and probably some other pump, some pre-pump for that one, sitting in here, which is basically creating this helium-3, helium-4 loop. On top of that, you also have another compressor sitting in that system, which is actually producing the 4 Kelvin stage and the higher temperature stage, which is using helium and then cryogenically, basically by pumping it back and forth through a very specifically shaped type of tube, you can create something like a heat pump. And that is what creates this very original sound. When you hear those systems, they make a very original sound. And this is basically this helium-4 based compressor stage. Now you see also this white vessel down here. This is actually a cleaning system. So now that you have your helium-4, helium-3 system and your 1K stage and so on, you actually want to make sure that, like, your system is continuously cleaned, and usually this system here is connected to the helium-3, helium-4 loop, and in here you put liquid nitrogen and you add some carbon active charcoal filter in there, and you basically pump the solution, you pump the mixture through this active charcoal filter to make sure, through this cryogenic active charcoal filter, to make sure that any other gas residues that might be inside the system because of some contamination, because something was not, let's say, fully evacuated, because something is evaporating from the stainless steel which is on the inside of the helium-3, helium-4 loop. This is all being cleaned out with this filter, which on a regular basis has to be refilled. So the system is not, let's say, completely autonomous. Somebody still has to go and refill this liquid nitrogen here every once in a while. And every once in a while you also might want to clean this. So that's, let's say, on the mechanical component side. And then of course you have a lot of valves which can automatically switch because you want to do different things with the system in different temperature stages that you are in. And you also have a control system in here, like a computer, which is controlling all the valves, all the pumps, and serves as your interface as a scientist to basically control this whole system. And that's, I think, let's say, what you can see here. Now, I was talking about the helium-4 compressor, which is making this very specific sound that you know. This is a component which is being created by a company called Cryomag. It used to be a separate company that is selling to many different cryostat manufacturers in the market and has been acquired, I think, by Bluefors. We can also check later on the press release. But again, so this system, I think, is very crucial for many of those companies, probably as crucial as the chip itself, because In order to create your superconducting qubit, you need these super low temperatures, and there's only a very limited number of companies that can create those systems. And we've already featured another one of them in the series, and there will also be others being featured in this series to come. So here we see some of the products. So we see the XL-DSL dilution refrigerator measurement system. That's the tube cooler. That's exactly the system from Cryomag that I was talking about before. And then we have here the DL dilution refrigerator measurement system. So I guess that is, and it also looks like that, this is like a bigger version of the cooler. This is a smaller version of the system. We have the Kite cryogenic platform, which is designed for large-scale quantum computing with the ability to support over 1000 qubits. And then we see here the HERL02RM helium reliquefier is specialized design for helium recovery from a single NMR unit, creating a closed loop zero boil off system for your magnet. So that's maybe also important to mention. What you see here is, of course, let's say the cooling system, and for some cases, for some specific experiments, and in let's say quantum material science and also quantum sensing, but also for some qubit designs, you might need to have a magnet down here, or a vector magnet. So magnets that can tilt the magnetic field in different directions, or magnets that only have a single direction of magnetic field that are superconducting. And these ones, they usually also go down here where the qubit or the quantum chip would be sitting. And they are connected to some upper stage up here, so that they also go to cryogenic temperatures, let's say 4 Kelvin, 1 Kelvin, whatever. Okay, and then we also see here the ultra-compact LD dilution refrigeration measurement system. The ultra-compact LD system is an all-in-one ultra-compact cryogenic measurement system based on our LD systems. Okay. Then what else do we have here? It says trusted across breakthroughs, Bluefors systems in action. And I guess we see some use cases here. Here, for example, from silicon quantum computing, it says our commercial scale quantum computer fits into one dilution fridge. This is exceptional science leading to superior economics of the commercial system. That requires the very best technology in cryogenic technology. This is why we partner with Bluefors. Then we have here from Duke University, overall having Bluefors and Cryomag systems at labs across the world enables us to share information, share knowledge, and develop shared hardware, making our operations easier in the field. Then we have here from the University of Pennsylvania, when we got the Bluefors system, it was a total game changer. The end user experience is just worlds away from what we are used to deal with. I actually joked it might put me out of a job, because it was push button simple, you click and it cools. And maybe a quick comment on that. I can say that, let's say in the last, so when I was working on my research during my PhD, I saw also systems from not only from our lab, but also from other labs, and then from various different times. So like systems that were 30 years old, 20 years old, 10 years old, and 2 years old. And I can definitely say that, let's say, what has been produced in the last 5 to 10 years in terms of systems, or shipped and being produced, is definitely much more user-friendly than, let's say, the very old stuff. Because in the very old stuff, you would really have to be an expert of the machine. You have to know exactly which button to press at which moment, because otherwise, first of all, you will not be able to cool it down. And secondly, you will create quite a big damage, because when you have these helium loops with the helium-4, helium-3 mixture in it, if you create a leak in there, you might easily just leak out thousands and thousands of euros or dollars or whatever unit of currency you want to choose of material, just somehow into, I don't know, a vacuum container or maybe even into the atmosphere. So you really had to understand exactly what the machine is doing, and you had to press the buttons in the right order and check different pressure measurements and so on. And even knowing all of that, it was sometimes kind of hard to know exactly what is going on in the system. Whereas now you really have these computerized and automized activities where you basically just tell it cool down, and then it goes through the whole procedure by itself. It checks all the different valves and clicks the valves and makes sure that always the system is in a safe state, that you don't, let's say, vent any helium outside, that you don't create a leak or an overpressure in some part of the system that can lead to a leak or that can lead to destruction of the system. So that is like, from a user experience point of view, really a lot of innovation happening in the last years, basically stripping away the whole set of cryogenics knowledge and understanding of those systems that previously you needed to have to actually operate them. There are some more case studies here from other universities that we are seeing, and also from institutes, I think, across the world. So we have various different ones, and then also from some companies in the space. Every cool second counts. Our services are designed to bring peace of mind and ensure that every cool second needed is available for you. We make sure each system continues operating at the best performance levels with maximum uptime for as long as possible, so you can focus on your work. And then here you can get technical support and explore their services. Now finally, what else do we have here? There's something on the people, so putting our cool heads together. At Bluefors, we operate in a world of code. We bring together physics, engineers, production and business professionals, and a whole lot more. What do we have in common? We all speak one language, progress. We are a company built on innovation. Our passion for progress is encoded in our DNA. We are a diverse group of bright minds from all over the world, striving to deliver nothing short of excellence. And quick comment on this all over the world part. So I think Bluefors itself is located in Europe, but I think you also might have seen it before in this news slider down. It said that they also opened a location in Chicago in the US. So it's really like it is an expanding effort. They have offices in multiple different locations, and I think in Chicago they also have a lab where they do some research on the cryogenic systems. And of course, in Chicago, there's a lot of research also in the quantum field going on. So they're also positioning themselves close to global quantum computing startups and also the global quantum computing ecosystem. So it's really like a company that is very deeply connected within the space of, let's say, at least solid state-based quantum systems. And then there's some more information here about the people and careers and the company itself. Think quantum, think Bluefors. Every day, scientists around the world are finding new solutions using the latest advances in quantum technology, and Bluefors systems are at the beating heart, cooling these quantum leaps. And then there are some news down here. So you see what I just said. Bluefors opens shared lab facility at the University of Chicago Science Incubator, expands Bluefors Lab Chicago. There's some news here on the new CEO at Bluefors. And then also here is some information about Bluefors and Delft Circuits joined forces on scalable quantum I/O for next generation quantum computers. I'm recording this in November 2025. This news, which you can see here, is from October. So I guess this is pretty much up to date. Then finally here, there are some information about the events and webinars that they are participating in. Here is, for example, November 16, which is very soon, the International Conference for High Performance Computing, which they are also participating in, I guess. And then it says, find your quantum advantage. And down here you see they are based in Finland, in Helsinki. Not the only company from the quantum field that we know that is located there. And then there's some more information here about the product, services, and so on. Now let's quickly also check out the product portfolio. So here we see that they have still both of the brands here. So there's Bluefors as one brand, and there's CryoMag, which is another brand going under the Bluefors label now. In terms of product categories, they have a whole lot of them here. So you see there's the Kite cryogenic platform, dilution refrigeration measurement systems. There's 1K systems, which is for 1 Kelvin. You can reach that with normal helium-4 and then basically pumping on it. You can go down to 1 Kelvin temperature. There's 4 Kelvin systems, which is basically liquid helium at ambient condition, more or less. There's a cryogenic wafer prober. So you basically take your whole wafer as it comes from the production, and you might want to do some testing before you actually continue to work on it to do the next stages of measurements. And for that you want to have a cryogenic wafer prober, because maybe your chip at room temperature has a super high conductance, so you need to actually cool it down, or you want to see if it actually becomes superconductive, so you need to cool it down. And for that they have this cryogenic wafer probers where you can do it really on the whole wafer scale instead of just cutting everything and then measuring chips individually, because this is meant to be, I guess, as a process quality measurement. Then you have measurement infrastructure, so everything that goes around the measurement itself. You see here they have high density wiring, coaxial wiring, so this is all the types of wires that go into the fridges. You also see optical fibers. For example, if you have optical qubits or let's say quantum cascade systems or single dot systems where you really can either optically activate them or create some photons with them, let's say single photon sources. For that you need optical fibers, and it's also something they offer here. On top of that you see cryogenic variable temperature noise source, IR filters, microwave readout modules, so that's very much on the electronic side of things. Then you see the magnets, which I talked about before, right? There's like vector magnets and solenoid magnets. You see cryocoolers. The pulse tube cooler is what I mentioned before from CryoMag, which makes this very specific sound, but there's also others here. You see helium management products, so liquid helium plants, helium reliquefiers, helium recovery systems, and compact recovery system. Quick comment also on that. When they talk about helium recovery systems, what I assume is in the old days when you could not put everything into a compact machine like a compact cryostat, what would usually be done is you would have on a research facility, let's say looking at Jülich Research Center, you have a lot of different labs, and some of them they might use liquid helium. And then what you basically do is you create another set of connecting pipes, usually copper pipes, and they basically all go to one facility, a centralized facility, which actually has the liquefier in it. And this liquefier is basically liquefying helium, and then it's getting filled into some helium vessels, and these are being shipped to the different labs that you have on site. And then the helium is transferred from these vessels into the cryostat with a helium transfer tube. And then in the cryostat it sits and it's being it evaporates, right? Because there's heat coming either from the measurement electronics or maybe from the outside because it's not perfectly insulated. So the helium is boiling off at 4 Kelvin. And then the helium goes from liquid to gas, and then the gas helium is actually being recovered with those copper lines going back again to this liquefaction place, to the liquefier. And then you basically create by this like a closed loop where you have liquid helium being shipped to your research facilities, to your labs, and then the gas helium is going back and being reliquefied. And that's how it used to be done before those, let's say, self-contained systems like the one from Bluefors, were being sold. And yeah, for this, you basically, of course, need a big system that can liquefy a lot of helium. So then you have, let's say, a helium recovery system, a big helium reliquefier, and so on. Then you see here cold helium circulation systems. What else do we have? Liquid nitrogen plants. Okay, so everything from the cooling space. Then there are also different services here. You see relocation service, training, health check, pulse tube cryocooler upgrade and refurbishment, gas handling system, Bluefors lab, customer care, and total system care, which is basically interesting for labs that want to work on, I don't know, for example, quantum computers, but don't want to investigate a lot of time into these cryostat systems. Let's say we saw some of those companies on the list before. You are a company which is dedicated towards building quantum chips, towards building quantum computers. Then, of course, the liquefaction system or the helium, the refrigerator is only part of the system, and you might not have enough experts around to take care of this all by yourself. So then you might want to have something like this total system care, where I guess Bluefors is taking care of everything. It says field services, rapid response service level, and configured to your needs. So they help you to build the right system and to keep it up and running. And they're also helping in case you need some support. And here are the different features of what they support with. And then a lot more information about the field services and the feature descriptions as well. Some applications. So what are the applications that they are enabling? We've talked about this before. So there's quantum technology, of course, but there's also low temperature physics research, as in having different materials that you want to cool down to see what are their quantum properties, for example. There's medical and life sciences. So we support medical and life sciences with liquid helium management products and reliable cryogenic products for cooling down systems. Think, for example, of your NMR machine, which has a big superconducting magnet in it, which needs liquid helium to actually work properly. And if you want to, for example, develop a new NMR system, you also need to have to have some access to liquid helium, to have somebody who's providing the cooling system for you, and I guess that's what they do. And then here you also see clean energy. Our cryocoolers empower companies who are transforming the world's energy production methods to cleaner alternatives. And there's also information about that if you want to learn more. Let's quickly also check out on the company. So here it says delivering the quantum future today. Bluefors is the world-leading manufacturer for dilution refrigerators, cryogenic measurement and infrastructure, cryocoolers, and other cryogenic product lines vital to quantum technology, fundamental physics research, and other selected industries such as medical and life sciences. With more than 700 employees globally, we deliver the most reliable, versatile, and easy to operate systems on the market under the Bluefors and Cryomag brands. The renowned quality of our products in combination with our scalable production capabilities make us the preferred choice for the ultra-low temperature requirements of university, research institutes, and corporations around the world. Our mission: we are here to enable the quantum technology breakthroughs, to support scientists and industries to go further, to allow new innovations, and to grow and care for your global community. The key figures: 200 million euros revenue in 2024, 1,500 cryogenic measurement systems delivered, 15,000 cryocoolers delivered, and 700 plus employees around the world. We see the different locations here. So that's the Chicago lab that was mentioned before. Here is the headquarter in Helsinki. There's also a lab in Delft and another one in Munich, another sales and services office in Munich. There is Bluefors Tokyo sales and services office, another one over here in Syracuse and in Brooklyn. Okay, then down here we see, I guess, the we see the different application sectors again. And how cool is that? What happens when you make something colder than anything else in the known universe? You serve the world's greatest challenges, and that's what we are all about. We operate in a world of cold, where quantum mechanics challenges our intuitive understanding of the universe. Our mission is to provide the most innovative, reliable, and easy to use ultra-low temperature systems ever made, so companies can harness the power of quantum technology. Our story began when we created our first prototype for a new dilution refrigerator, allowing physicists to reliably reach millikelvin temperatures for the first time. Since then, our constant research for perfection has made us preferred choice for reliable cryogenic measurement systems, cryocoolers, and groundbreaking cryogenic products. And here we see one of those systems, and I guess an employee from Bluefors. Cool problem solving in our DNA. I, by the way, like the word jokes with cool and cooling. We are people from different cultures and backgrounds based all over the world with a vast array of expertises, but we all speak one language, progress. As physicists, we understand low temperature conditions better than anyone. As engineers, curiosity is at our core, and as business professionals, we know that every obstacle has its own unique solution. We seek out and solve the most difficult problems so our customers can focus on their mission and reach their goals. We have come a long way and will never stop innovating. Our team proudly delivers the future today, and we are there for our customers over the lifetime of their system, providing unbeatable support throughout their journey. And then there is some more information about governance, leadership, sustainability, suppliers, policy, certifications, and so on down here, as well as an opportunity to subscribe to their newsletter and file a Speak Up report down there. And with that, I think we are already at the end of today's company check on Bluefors. So again, we have one of the companies that is maybe not super prominent in the whole story of creating quantum chips and creating more qubits, but is actually very vital to the whole field. You saw a lot of labels that are buying systems from Bluefors. You saw they are already creating a lot of revenue with this whole system because they are part of the infrastructure, of the very core infrastructure of some of the quantum systems, and also some like quantum computing, sensing, and communication systems. So I think one of the very important companies in the field, and also as a former researcher, one of the very important companies in the daily work, besides other ones, of course, that are catering a similar market with similar products. So definitely a company worth checking out. With that, as always, make sure to stay hydrated. If you want to see another video, also check out our Hidden Quantum Champions playlist with all the videos from this series, which is linked in our channel. If you have made it all the way here, congratulations, and then see you in the next one. Bye-bye.